quick review. So far this term we've looked at the different types of changes, and we've investigated physical change a lot more so that we can look at some of the advanced stuff with physical change. So why physical change is occurring, what's actually happening to the atoms and the particles of the substances to make physical changes occur. We've looked at atomic structure and density, and finally we're going to go back to where we began with the types of change and just make sure that we're very clear on how we tell the difference between these two, physical and chemical changes. So at the very beginning we talked about the difference being that physical changes where you have the same substance, it's just changing shape or it's changing state, but it's still the same substance. So water can go to ice, can go back to water. It actually hasn't changed the chemical that's in that water. It's still H2O. It's just in a different state. The difference with physical change and chemical change is that when you have a chemical change, you make something new from the old substance or substances. So you take the substances that you have and you rearrange them to make something new at the atomic level. And that's what we're just going to quickly review right now. You've got to get into your head the difference between physical and chemical changes. Physical means it's the same thing, so you've either cut it or bent it, you've changed it from a solid to a liquid and back, a gas and back again. You might have mixed it up with other substances, but they're still the same substance mixed in there. If you used certain techniques like filtration, you could actually separate them back out again. And also dissolving. A lot of people forget that when you dissolve something into a substance, like dissolving sugar into water, you can get it back by evaporating the water. They are still separate in there, otherwise evaporation wouldn't work. So all of these are evidence of a physical reaction or physical change occurring. Now the next one here is chemical reactions. We reviewed this at the beginning, but let's go over it in a bit more detail. If you have something new being made, you're going to see some evidence about that. You're going to see possibly a new substance being made that has a different color to the old substance that you mixed in. So you'll see a color change, a permanent color change, because the new substance is now different from the original one. You may see gases being produced in the form of bubbles. Or if you don't see bubbles, if it's a very slow reaction, you may just smell it instead. When food is going off, you can definitely smell it, but you don't always see bubbles being produced. But that's because as the food breaks down, a gas is being made from the atoms that were in the food. You will also see this being made, a precipitate. Now this is where you produce a solid from usually two liquids that were before. So when you mix two substances that were liquids and the new substance that they rearrange and make is actually a solid instead of a liquid, you'll see a solid drop out of the solution and fall to the bottom of the test tube or whatever you're mixing things in. This is a very clear indication, a temperature change without you actually doing anything. So you can heat something up or cool something down, but when you mix two substances and don't add any energy to it, you don't try and heat it up or anything to make it work, but you still get a temperature change, then you know that a chemical reaction is definitely occurring because it's either releasing energy or absorbing energy as the chemical change occurs. So there, in a nutshell, is the difference between physical and chemical changes. Now you're going to go a little bit more into what is happening to make a chemical change occur.